Today we're going to talk about the story of statistics. But wait, don't tune out. This isn't about your boring high school math class. We're talking about statistics as this incredibly powerful tool that data scientists use to find clarity in a really messy world, and ultimately to help all of us make much better decisions.
So let's just jump right in with a question that companies, big and small, wrestle with every single day. A choice that seems almost trivial can have huge consequences for the bottom line. So, how do you know you're making the right call? How do you get beyond just a gut feeling?
All right, let's look at a classic example. You've probably heard of this, the A/B test. Imagine a website with a Buy Now button. We're testing two versions. Option A is red. Option B is blue. The question is simple. Which color gets more people to click?
Okay, so we run the test for a while and the results are in. The blue button gets a 5.4% conversion rate and the red one gets 5.1%. So there you have it. Blue is the winner. Case closed, right? Well, not so fast. Here's the real million-dollar question. Is that tiny 0.3% difference a real thing, a repeatable pattern, or was it just, random luck? Maybe that day a few more people who just happen to like blue showed up. This is the core challenge statistics was invented to solve, separating the real signal from all the random noise.
To figure this out, we have to stop guessing and start thinking like a data scientist. And that means understanding two really different ways of looking at a problem like this.
It really comes down to the difference between probability and statistics. See, probability is all about reasoning forward. You know the rules of the game, like, a coin is fair, and you try to predict what's going to happen. But statistics works backwards. You have the results, the data, and you're trying to figure out what rules or what process could have possibly created it.
A simple die roll makes this crystal clear. Probability asks, hey, if I have a perfectly fair die, what should happen? Statistics looks at the result and asks, okay, I got 25 sixes. Wait a minute. Is this die even fair to begin with? With our button problem, we're doing statistics. We have the data, and we're trying to work backward to the underlying truth of which button is actually better.
So how can we possibly be confident that what happened in our little test applies to everyone who ever visits our site? How do we go from a small sample to the big picture? Well, this is where a really beautiful idea in math comes to the rescue.
It's called the law of large numbers, and it's basically the foundation that makes all of this work. It says that any single event might be totally unpredictable, but the average of many events becomes incredibly stable and predictable. The more data you get, the closer your sample average gets to the real truth.
And this isn't some abstract theory. I mean, think about it. The entire multi-trillion-dollar insurance industry is basically one gigantic bet on the law of large numbers.
Look, your insurance company has absolutely no idea if you are going to get into a car wreck this year. That's totally uncertain. But they can predict with stunning accuracy how many accidents will happen on average across millions of their customers. This law turns individual chaos into predictable group behavior, and that's what allows them to run a business. Okay, so the law of large numbers lets us trust an average, but data is usually way more complicated than that. A lot of the time, we need to understand the relationship between different things, and for that, data scientists have another really powerful tool.
It's called regression analysis, and it's just a fancy way of saying we're trying to understand how one thing affects another. It helps us answer questions like, hey, if we spend $1 more on marketing, how many more sales should we expect? It's all about finding those hidden patterns.
But here's the thing, before you jump into any of this fancy math, there is one step you absolutely cannot skip. It's like the golden rule of data science. You have to plot your data. You have to look at it, because just looking at the summary numbers, well, they can be really deceiving.
Take a look at this table. It shows the summary stats for 4 totally different data sets. Now notice something weird. The average of X is the same. The average of Y is the same. The correlation is the same. I mean, all the key numbers are basically identical.
So, just by looking at the numbers, you would be totally justified in thinking these 4 data sets are telling the exact same story, right?
And nope, not even close. This is a famous example called Anscombe's quartet. The second you actually plot the data, you see they are telling 4 completely different stories. One is a nice, clean line. Another is a curve. One has a huge outlier messing everything up. If you had only trusted the summary numbers, you would have been completely wrong. This is why you always plot your data first.
And these tools aren't just for website buttons. They have huge, real-world impacts. Take the city of Chicago, for example. They want to make their roads safer.
They can use regression to look at all their accident data and figure out what really works. Is it adding more traffic lights? Is it improving the road surface? Regression helps them untangle all those factors to make the smartest investments to save lives.
So, let's pull all of this together. Because at its core, statistics isn't really just about math. It's a way of thinking. It's a tool for intellectual honesty.
The brilliant physicist Richard Feynman put it perfectly. The biggest challenge we face is our own desire to believe something is true. We are so easy to fool. We want the blue button to be better, so we're incredibly tempted to just jump to that conclusion. What statistics does is it gives us a weapon to fight that urge. It gives us a framework to actually measure and quantify our own uncertainty. It doesn't give us absolute truth, but it tells us precisely how confident we should be in a result.
So how do you actually do this? It really comes down to 3 simple steps. 1, you start by acknowledging that you don't know for sure. 2, you go out and systematically gather data to try and reduce that uncertainty. And 3, you use the tools of statistics to measure just how confident or uncertain you should be in your conclusion.
So what does this mean for our blue button? It means we don't just declare victory. That 0.3% difference could very well be just noise. To be sure, we need to keep collecting data. And you know, this applies to so much more than just marketing. We all face these high-stakes decisions. So I'll leave you with this question. What's the most important decision in your life right now where you absolutely cannot afford to fool yourself?